Assalamualaikum. My name is Uzma Senina binti Muhammad Fuad. My matric number is B0324109009. Now I will explain about introduction. Our project focus on securing a medium-sized company that hosts internet servers and provide network services to both employee and external users. These servers store sensitive data like user credentials, system logs, and also organizational information. The organization faces several cybersecurity threats, including unauthorized access attempts, false attacks, malicious network traffic, and also intrusion attempts. This threat can compromise data confidentiality, integrity, and also availability. To protect the organization, we implemented a layered security approach using three main tools, which is UFW, a firewall that controls network access; Snort, an intrusion detection system that monitors and alerts on suspicious activities; and also FAIL2BAN, which monitors logs and automatically blocks attackers.
Hi, my name is Siti Nabila. I'm going to present the objective of this project. The first objective is to implement a layered network security solution for a medium-sized organization using open source security tools on a Linux platform. Second, to install and configure UFW uncomplicated firewall to control network access and block unauthorized connection. Third, to deploy and configure Snort as an intrusion detection system IDS to monitor network traffic and detect suspicious activities such as scanning and probing. Lastly, to implement FAIL2BAN as an automated response mechanism to block IP addresses that exhibit malicious behavior based on log analysis.
And then for the installation demonstration, first one is Snort installation. Snort intrusion detection system installation was done on Ubuntu Linux, and this was done by updating the local package repositories and installing Snort binary package. First, we need to run sudo apt get update to fetch the latest package list from the repositories to ensure all dependencies were met. And then to finally install Snort, we need to run this command sudo apt install snort-y. And then to check that the installation was successful, we need to run command snort-v in the terminal. And this screenshot shows the Snort installation is successful when we run snort-v. Next, for the FAIL2BAN installation, package installation, we need to execute sudo apt install FAIL2BAN-y to download and install the service. And then for the service activation, we need to start and enable the service to ensure it runs automatically on boot using command sudo systemctl start FAIL2BAN, sudo systemctl enable FAIL2BAN, and lastly sudo systemctl status FAIL2BAN to see the status like the picture. And this is the screenshot of the FAIL2BAN installation that has been successful.
Assalamualaikum, my name is Anas bin Muhammad Izan. So my number metric is B0324109903. So my part is installation demonstration for Ubuntu VM. So this is the text that we want to talk. So the first one is virtual environment setup. Ubuntu Linux was necessary to have a virtualized testing environment that was well controlled, and to achieve this, a dedicated virtualized environment setup was done before installing the security service like Snort and FAIL2BAN. The project was applied on Linux environment on VMware Workstation. So number 2 is virtualization program. This is a VMware Workstation. And number 3 is operating system. The operating system is we use the latest one, Ubuntu 24.04.3. And the number 4 is security service, hardware configuration. Number 5 is memory RAM, we use 4 GB RAM. And number 6 is processor, we use 2 cores. Number 7 is hard disk, we use 40 GB. And the last one is number 8, network data, we use NAT mode to set to enable the VM to interact with external repositories, but in relation to a private IP register test. So this is the picture that with Ubuntu VM installation. Thank you.
Assalamualaikum, my name is Anas bin Muhammad Izan. So today I want to show you how to install Snort. So first thing first, type sudo apt install Snort, and then wait until the installation complete. After that, to see the Snort is already complete installed, type sudo snort space -v. Thank you.
Okay, for the FAIL2BAN installation, first we need to run sudo apt update as in the video. Then, when the previous command is done, we need to run new command to install the FAIL2BAN, which is sudo apt install FAIL2BAN ufw-y and click enter. And then wait until the installation is completed. Okay, now as you can see, the installation is already done.
So, okay, Assalamualaikum. My name is Muhammad Zain Belatit and my nomatic is B0324100891. So, I will talk about configuration demonstration for Snort. So, first, we go with Snort configuration overview. Configuration scope. Creation and modification of custom Snort rule using local.rules. Implementation of pass rule to filter banic traffic, and implementation of alert rule to detect suspicious activity. The importance of the configuration is why ensures not monitor traffic based on project requirement, prevent excessive alert caused by normal background traffic, improve the reliability and readability of security alerts. Without proper configuration, and IDS may generate too many irrelevant alerts. This configuration ensures not focus on meaningful security event. Okay, for number one, I'm going to talk about configuration of custom Snort rule. The configuration method is custom rule are defined in /etc/snort/rule/local.rules. Rule are edited using the nano text editor, and default Snort rule set are preserved to maintain system stability. Why local.rule is used? Because allow safe and control rule customization, simplify testing and demonstration of IDS behavior, and lastly provide a clear separation between default and project specific rule. Using local.rule allow us to customize short behavior safely without affecting the default detection rule. For my point number 2 is noise filtering configuration. Pass rule implemented, IPv6 traffic is ignored to reduce background network noise. Multicast and broadcast traffic such as SSDP, UDP 1900 and MDNS UDP 5353 is excluded. And then SSH traffic on TCP port 22 is ignored to prevent alert from normal automated access. Purpose of noise filtering is reduce alert fatigue for administrator, improve IDS performance and efficiency, ensure alerts represent potential threat instead of normal operation. Noise filtering is important because an IDS should not alert on normal traffic. This rule helps not focus on suspicious activities. So point number 3 is intrusion detection rules configuration. ICMP ping detection. Detect ICMP echo request commonly used for reconnaissance. Confirm that Snort is actively monitor network traffic. Provide simple clear validation of other functionality. Okay. Keyword based detection. Detect suspicious keywords such as attack using TCP payload. Demonstrate content based packet inspection and simulate basic malicious communication attempts. Reason for rule selection. Rules are simple, efficient and easy to demonstrate. Detection rules are observed and verifiable, suitable for academic demonstration and testing. This detection rule demonstrate both packet header inspection and payload analysis, showing how Snort identifies suspicious behavior. And lastly is the configuration, justification and outcome. configuration outcome, background network noise is significantly reduced. Alert generate are focused and meaningful. Suspicious activity are clearly detected and logging. Overall justification, configuration align with ADS best practice, enhance visibility of network security event, meet the project requirement for configuration demonstration. Overall, this configuration proof that Snort can be effectively customized to function as reliable interaction detection system.
Assalamualaikum and good day. My name is Ahmed Fanasim bin Aminuddin. My number matrix is B0324109004 and I will explain about the configuration demonstration for FAIL2BAN and firewall. So firstly, the FAIL2BAN configuration overview. The configuration scope is firstly creation and modification of custom FAIL2BAN rules using jail.local, and then we have the detection scope. It is to detect what triggers a ban, and then monitoring scope to detect FAIL2BAN watches. The importance of configuration: firstly, it converts alerts into automatic protection, adding real-time response capability, and it minimizes administrator workload because FAIL2BAN will handle the blocking, and then admin will reduce fewer repeated incidents, and the logs will stay cleaner and more useful. The configuration of FAIL2BAN. The first configuration is monitoring scope. In var /log/snort/snort.alert.fast, the jail will tell FAIL2BAN to monitor snort alert. FAIL2BAN will react only to events detected by snort. And the second configuration is the detection scope, which is the filter equals snort config links to a FAIL2BAN filter that defines which snort alerts counts as malicious and which signatures or keywords triggers bans. The second one is the firewall configuration overview. The configuration scope. The first one is blocking incoming traffic from the attacker's IPs. The second one is time and threshold scope, and the third one is enforcement scope, which will tell how blocking is applied. And the importance of configuration: firstly, it will help protect network services, SSH, web services, and applications. Secondly, it will block hostile IPs before further damage. And the third one will change it to automatic enforcement. For the configuration of firewall, the enforcement scope: by deploying action equal UFW, the enforcement is applied using UFW firewall rules, and then it will block incoming traffic from the attacker's IP and adding a temporary UFW reject rule. And the time and threshold scope: adding max retry equal 1 and ban time equal 600 will make an IP is banned after one malicious event, and the ban duration will be 10 minutes. That's all from me. Thank you.
Okay, next I will explain about the security testing and attack simulation. First of all, Snort. During the attack simulation, Nmap code scan was launched. The Nmap is an open source tool used for network discovery and security auditing. It also scans hosts on a network to see which devices are active, and also detect open ports and the service running on them. So Snort monitor incoming network packets and analyze them against its rule set. Okay, now I'll show the demo. So the Snort is running in monitoring mode, confirming that is properly configured to capture and analyze network traffic in real time. During the testing phase, Snort continuously inspects incoming packets and compare them against its predefined detection rules. So when the attack activities are initiated, including the Nmap port scanning and ping probing, the Snort successfully generated alert messages. This alert displays important details such as the attacker IP address, protocol type, and detection timestamp. The result confirms that Snort is effective in identifying abnormal activities and provides early warning of potential security threats. Okay, now I'll show the demo. So the Snort is running in monitoring mode, confirming that is properly configured to capture and analyze network traffic in real time.
Just like the previous demonstration, Snort successfully has detected the Nmap scan or even other attacks that has been done by the attacker IP address. But just detecting and monitoring the attacks is not gonna fully secure a network. So for that we are using FAIL2BAN, which is gonna trigger a ban command so that the attacker IP address will be banned from connecting to the network ever again. After receiving a ban command from FAIL2BAN toward an attacker IP address, the UFW unfiltered firewall will check the rules and then verify the attacker IP is banned successfully blocked from connecting or attacking a service or an or a target anymore. This is a sample full testing simulation that we done with Snort and File2Ban services. Here we can see a sample and met attack triggered by an attacker, which is our VM itself, is causing Snort to generate alert logs. And on the right side, we can see the fail to ban software is showing logs that the attacker is attacking and generating a ban command on the IP attacker IP to the UFW firewall so that later it will be rejected from trying to connect again, which means the firewall will ban the attacker IP from trying to connect again. So, in conclusion, this test proves that our setup function is a complete intrusion prevention system. We successfully close the loop between detection and mitigation without any human intervention required. This is a sample full testing simulation that we done with Snort and File2Ban services. So this is our final test result. Firstly, we can see the attacker IP is being banned and rejected by UFW firewall from connecting to anywhere or any other IP address. After that, we tested that by curling and trying to access a website with the attacker IP, but it got connection diffused, which means the IP is successfully being banned and rejected by the firewall. So this test result approves our security concept, which is basically Snort ideas is detecting an attack, fail to ban, log monitor, detects the log generated by Snort, and then ordering firewall, commanding firewall to block the attacker IP, and then the firewall blocking and dropping down attacker IP, so that the attacker can't attack the same network again. Thank you.